everyone, my name is Kenjanay Caballo from BSc 3I of College of Engineering in NAST. Today, I am solving a rotational motion problem. So let's begin. So we have a problem. A wheel is rotating freely at 1800 RPM clockwise. It is subjected to a variable counterclockwise torque which is applied at time t is equal to 0. The torque produces a counterclockwise angular acceleration alpha is equal to 40 rad per second squared, where t is the time in seconds during which the torque is applied. Calculate the following, which is the time required for the wheel to reduce its clockwise angular speed at 900 RPM, the time required for the wheel to reverse its rotation, and finally, the total number of revolutions, clockwise plus the counterclockwise, turned by the wheel during the first 14 seconds of the torque application. Now for the first part, the problem requires us to find the time required for the wheel to reduce its clockwise angular speed to 900 RPM. So yung unang speed natin, we have 1800 RPM and magiging 900 RPM. The problem states that acceleration is equal to 4t rad per second squared. And sabi, counterclockwise yung acceleration. Meaning, itong clockwise na to, magiging negative sila kasi ang pagbabasihan natin is the counterclockwise rotation. So, negative. Pinapahanap sa atin is time equals to what? Para makita natin itong time, we will use the formula of acceleration is equals to dw, derivative of angular speed in respect to time. So, pag inayos natin yung formula na yan, dw is equals to acceleration dt. Tapos, integrate natin both. Since yung acceleration natin ay nasa rad per second squared, we need to convert the 1800 RPM and 900 RPM into rad per second para maging velocity sila na paplagin natin dito sa W. Itong 1800 RPM ay magiging negative 60 pi rad per second. Ito namang 900 ay magiging 30 pi rad per second. Yan. Next, ipa-plug in na lang natin itong mga value na to para sa formula natin. So, dW from 1800 RPM, so negative 60 pi into W is equals to acceleration natin which is 4t dt. Nagmula sa 0 kasi 0 in the time of 0, 1800 RPM pa lang siya. And we need to find the time. So, kapag in-integrate na natin to, ang makukuha nating value ay W is equals to negative 60 pi plus 2t squared. Kasi pag nilabas natin yung 4, nagkakaroon 2 squared to, and divided by 2, magiging 2 naman siya. So, ito na yung magiging bagong equation natin. Pwede na natin i-plug in yung sinasabing 900 RPM or negative 35 per rad per seconds para makikita na natin yung time. So, kapag negative 30 pi yung angular speed is equals to negative 60 pi plus 2t squared, nakikita natin si t kapag inayos na natin to. So, negative 30 plus 60 magiging 30 divided by 2 equals to 15. So, t squared equals to 15 pi. Kapag in-square na natin yan, square root dito, t is equals to 6.86 seconds. Ito na yung sagot sa una. It will take 6.86 seconds for the wheel which is rotating from 1800 RPM into 900 RPM clockwise. For letter B, we need to find the time required for the wheel to reduce its direction of rotation. So, to reduce its direction of rotation, so the problem stated that the wheel is rotating freely at 1800 RPM clockwise. So once it stops rotating clockwise, it will become, the angular speed will be 0. So we will use this in the equation that we got from earlier, which is W is equals to negative 60 pi plus 2t squared. So substitute the 0 there. Negative 65 plus 2t squared, and move the negative 65 there and divided by 2. So t squared is equals to 35. Once you root it, so t is equals to rooted 9.71 per seconds. This is the answer for letter B. It will take 9.71 seconds to reduce the direction of rotation from 1800 RPM clockwise. For the final part, we need to find the total number of revolutions clockwise plus counterclockwise turn by the wheel during the first 14 seconds of the torque application. So, di ba sa may letter B, nakuha natin na time it took from the 1800 RPM clockwise para maging 0, para tumigil siya, it took 9.71 seconds. So, hanapin natin yung revolutions na nangyari during that duration. And next, sa 9.71 hanggang 14 seconds na naging counterclockwise na yung rotation, hahanapin natin yung revolution sense. Pagpaplasin natin, yun yung magiging sagot natin sa letter C. So, in order to find the revolution, we will use the formula of W is equals to D in terms of theta in respect to time. Ayusin natin yan para ma-integrate natin. D theta is equals to W dt integrate. Ang gagamitin natin W, yung nakuha natin sa number 1, which is negative 65 plus 2t squared. So, sa may una nating integration, gagamitin sa may 0 to 9.71 seconds, hanapin natin yung number of revolution. So, d theta from 0 revolution hanggang sa hinahanap natin, so negative 65 plus 2t squared dt from 0 second hanggang 9.71 seconds. So, ang theta natin sa una ay negative 65 plus 2 over 3 t cube 0 to 9.71 seconds. Kapag sinasubstitute natin itong 9.71 seconds sa letter T, ang makukuha nating revolution dito, radians dito, ay negative 120 radians. Itong negative 1220 radians, ito yung magiging bagong starting point sa next integration natin. So, sa next integration na tayo, negative 1 to 0, hahanapan yung pinaka-final na revolutions, and yung time natin, negative 65 plus 2t squared dt from 9.71 seconds hanggang 14 seconds. So, kapag in-integrate na natin yan, meron tayo na 1, 2 to 0 equals to 65 plus 2 3 t cube over 9.71 and 14. And substitute yan, para ito rin dito. So, may makukuha tayo na 1220 equals to 410. So, meron tayong 1630 radians. Yung 1630 radians na yan, i-convert natin sa revolution. So, in order to convert that in revolution, didivide natin siya sa 2 pi. So, 1630 divided by 2 pi is equals to 259 revolution. So, from 0 seconds hanggang 14 seconds, meron tayong 259 revolutions na nangyari, counterclockwise and clockwise.